So Stuart Russell is a professor and formerly chair of the electrical engineering and computer science at the University of California, Berkeley. He's wrote a book called Artificial Intelligence, a Modern Approach with Peter Norvig, who is today the standard text in AI and has been translated into 13 languages and probably more, and used in more than 1,300 universities, 118 countries. He actually has received numerous awards, too many to mention, in fact. His research covers a wide range of topics in artificial intelligence, including machine learning, probabilistic reasoning, knowledge representation, planning, real-time decision-making, multi-target tracking, computer vision, computational psychology, global seismic monitoring, and philosophical foundations. In 2016, he founded the Center for Human-Compatible AI at UC Berkeley. His most recent book, Human Compatible, Artificial Intelligence and the Control of Artificial Intelligence and the Problem of Control, asserts that risk to humanity from advanced AI is a serious problem, despite the uncertainty that we have towards future progress of an AI. He also has proposed an approach to the AI control problem, which he probably will talk about today. Dr. Russell is a member of the World Economic Forum Council in the Future of AI and Robotics, and has also worked with the UN developing a global seismic monitoring system for a nuclear ban treaty. So Stuart, we have been working together on progress on AI technology, and we talked many times about the impact of AI on humanity and society, and also on the way that AI is not just good, but also could be dangerous and not safe. But when it comes to beneficial AI, how should we today, after 5 years of talking about if we good, think about the term beneficial AI?
Well, so that's the subject of my talk. But before I get into that, I think we have to make a switch. So this is what I'm going to say is we have to make a switch from the way we've been thinking about AI, which is essentially machinery that we put in motion to achieve an objective that we specify. We have to switch to a different way of thinking about it as machinery that is coupled to us, that the objectives are what we prefer the future to be. The AI is designed specifically to be an assistant to humans. And if cockroaches want to design their own AI to be beneficial to them, they can do that. But for the time being, we're going to build AI that's beneficial to humans. I think for reasons that I'll explain, I think we sort of missed out on that very important idea at the beginning. Okay, so it's wonderful to be with everybody in virtual space. I'm very sorry that I can't be in Geneva. These are some of the most enjoyable, inspiring meetings that I've ever been to. So I apologize for those of you who heard my talk in 2018, because you know the punchline of this slide. So the conference is about AI for good. And the basic reason why we can use AI for good is that we use our intelligence for good. The good that we are able to do is the result of our ability to understand the world and to make changes in the world for the better. And if things go well, then we can use AI to dramatically expand what we can do with our intelligence. So presumably we can do a lot more good. And there are amazing examples of collaboration. So in one project, 20,000 teams from 150 countries showed how to collaborate to improve the capabilities of AI systems for an important goal. So for those of you who didn't hear my 2018 talk, you can think about what project it is, which massive international collaboration I'm referring to. And actually, if you were listening to what Amir said, 150 countries is more countries than are actually using the AI textbook. So this is a pretty amazing collaboration. And the question you have to ask is that the best we can do? Is Netflix movie rating prediction really the pinnacle of our ambition for global collaboration in AI? So you might say this is a pessimistic slide, or you might say it's an optimistic slide, right? It says, look, if we can get that much collaboration just to improve movie rating predictions, think what we can do if we have really meaningful and important goals, and we put our collective minds to it, we can make a huge difference. Now, of course, there are things going on in AI besides movie rating prediction. And some of them are actually pretty important and pretty impressive engineering efforts. So the self-driving car is taking longer than we expected, but it's moving forward, and it will revolutionize cities and have beneficial impacts on traffic, on fuel consumption, and it fits very nicely with electrification. We also have seen AI defeat the world's best Go players, and this was an event that some people have described as the analog of the Sputnik moment that initiated the space race. And in object recognition, we've seen incredible progress on tasks such as the ImageNet database, which is a very large database of images, and algorithms on this testbed are now exceeding human capabilities. So all this is very important progress and suggests that there are technological capabilities now that could really be rolled out and applied to important problems. There are a few cracks appearing. So this is a paper from Dave Gifford's group at MIT, where they examined sort of forensically how exactly are these deep networks recognizing objects in the ImageNet data. So if you look at the left column, this is an image of somebody in a parachute. And you know, when we look at that, we don't have very much difficulty in recognizing that this is a parachute. But when they find, okay, which are the pixels that the algorithm is paying attention to when it does the classification, those are the red pixels. And then down here, we just extract the pixels that the algorithm is using. And you see that the algorithm is recognizing this is a parachute entirely by looking at the sky pixels. And in fact, a pretty small subset of the sky pixels. And this is repeated across a wide range of categories and a wide range of data sets and a wide range of deep networks that you see this kind of pathological, from our point of view, classification behavior. It's not pathological from the machine's point of view. All it's doing is finding the simplest way to correctly classify all the training data. And it turns out that because of the statistics of the training and test sets that are used, these classifiers are actually perfectly effective, in fact, superhuman, even though they're not looking at the objects at all. And that should worry you if you're thinking that you're going to build real-world systems such as self-driving cars that rely on these classifiers. So if you look at the column towards the right with the traffic light, you wouldn't want your self-driving car to recognize traffic lights simply by looking at the sky. That would be quite worrying. There is another big area of AI that's growing rapidly called parabolistic programming, which is almost the complement of deep learning, where deep learning is primarily about fitting very, very complicated circuits to large amounts of data. Parabolistic programming allows you to bring to bear prior knowledge about the domain, and the parabolistic programming systems can perform reasoning with that knowledge. So roughly speaking, getting into a little bit of technical detail, it combines probability theory with Turing equivalent expressive power, whether that's through first order logic or through a general purpose programming language. You get a universal modeling capability, which means that any formal model in probability theory in any formal language can be written in one of these languages concisely. Plus, we have general purpose algorithms which can do reasoning on any model in these languages and answer any query with respect to any evidence. And that includes learning from data as well as reasoning in a zero-shot manner. And just to illustrate the idea, I'm not going to go through this line by line. This is the NetVisa model, which Amir mentioned. This is the model for seismic monitoring for the global nuclear test ban treaty. So this is up and running in Vienna at the CTBTO and is the core algorithm that is monitoring for the nuclear test ban treaty right now. It's monitoring the entire planet and detecting events. Here's one of the events from 2013, a North Korean nuclear test that took place. And the algorithm was able to not only to detect it immediately, but actually to get a more accurate location than the assembled minds of the world's seismologists. Another interesting application, this is from my colleague Vikash Mansinka at MIT. You can build vertically integrated models for pandemics, meaning that you have data at all scales, from the individual who's wandering around campus with their cell phone, perhaps creating proximity and therefore possible contacts with other individuals, all the way up to data at the county, the state, and the national level. And all of that data can basically flow through a massive probabilistic model vertically from individuals up to national scales, and horizontally, so to speak, across the country, to help you learn more about the disease and how it functions, how it spreads, who has it, where resources are needed, and so on. So probabilistic programming is growing very, very rapidly. This shows the number of papers published in the area, reaching about 2,000 papers last year. So I see the coming decade actually as a decade in which the pendulum is going to swing back a little bit away from purely big data, big circuit machine learning approaches towards sort of hybrid, where we combine big data with the ability that probabilistic programming provides to add human prior knowledge, for example, about space and time, which we don't need our networks to discover for themselves, about diseases spread by proximity, et cetera, et cetera. So I think it's also worth mentioning, and this is sometimes lost in the way we talk about AI these days, that good old-fashioned AI is still alive and well, and actually playing a very significant role. So one simple example is that, for example, in the Google search engine, the knowledge graph has now grown to about 500 billion facts, describing 5 billion entities, and is helping to answer more than a third of all the queries that run through the Google search engine. We also have really increased the capability for formal reasoning systems. And one example is that we can now do verification and synthesis for very, very complex hardware and software systems, all the way up to full-sized operating system kernels. These technologies are now being applied every day in manufacturing, logistics, construction, to build and monitor and execute very complex plans. So this will be a very, very useful capability for the SDGs going forward, for example. But also good old-fashioned AI is in all of these examples that I've mentioned. So AlphaGo, although we often think of it as a success for deep learning, is actually a very traditional state space planning system, pretty much in the way that Aristotle outlined 2,500 years ago. And the way most self-driving cars are also adopting the same basic idea, that they're looking at the current state, they're looking at the other objects, they're reasoning forward in time, here's what I could do, here's what they could do, which of these courses of actions that I could take is going to be best for me and for the other vehicles. And even ImageNet, which you might think is just pure deep learning, but it has built into it a rock solid commitment to good old-fashioned discrete symbolic categories, because that's what the test is, right? If discrete symbolic categories were useless, why would we be applying machine learning to recognize their presence in images? And it's because the world is made of things, and the things belong in categories, as people have been saying in good old-fashioned AI for more than 60 years. And so that's why you would like to be able to recognize them. So I think there's actually an enormous amount that we could do with current technology. I thought about having lots of fancy slides with, you know, I love showing satellite images of the Earth because they're so beautiful and varied and interesting. But I'm not going to do that. I just want to point out that we, right now, with what we have, we could be delivering, you know, basic forms of computer-mediated education through cell phone networks. The X Prize Global Learning competition, for example, showed that this is possible, and you can teach people through this approach quite effectively in a fairly short time. And there are a number of consortia aimed at doing something similar with healthcare advice for people who don't have access to very expensive, well-trained human doctors. Through satellite imagery, you know, there's already Forest Watch, which allows us to detect illegal deforestation. We can do similar things, for example, in detecting illegal fishing. There was an article just a couple of days ago about illegal fishing around the Galapagos Islands detected from satellites. The World Bank is very interested in being able to detect potential famines as early as possible. Amazingly, we still have famines that arrive as a huge surprise to the rest of the world. They're not a huge surprise to the people who are living there on the ground in that area, but it often seems that we're unable to detect the warning signs by integrating data from movement of people, from price transaction data, from hydrology, from crop status, all of which, all of that data is available. It's just not being monitored and integrated. This is very much a model-based kind of application, because we don't have you know, data on 20 million famines happening in the modern era. We only have a few. So if we're going to be able to build detection systems for famine, we have to use models of how food is produced, how prices change depending on circumstances, where people are, what freedom they have to move elsewhere, et cetera, et cetera. And on climate, I think AI can contribute enormously in terms of improving the capabilities of these integrated models, not just models of the atmosphere or models of the ocean or models of migration, but models that combine all of these things so that we can understand both how things will evolve under the sort of do-nothing policy, and then which kinds of interventions would be most effective. And so in all these applications, I think it's the case that the amount of effort and the cost that has to be put in upfront is very significant. For example, for satellite data, to have a system that is able to receive all of the global satellite data that's available and store it and process it through computer vision and machine learning algorithms to do whatever it is that you want to do with your application, would probably cost on the order of, between 500 million and $1 billion to create that infrastructure that would allow your system to run 24/7 and provide a global service. And everybody in the humanitarian sector complains that there are all these wonderful prototypes where somebody basically begged one of the satellite operators to give them some data and showed that if we had that data, we could do this amazing thing. And then they write a nice report about it, and ESA, for example, has what they described as shelves full of reports about successful prototypes that went nowhere because there isn't the ability to run a 24/7 global service because the upfront cost of creating the infrastructure for that is too high. But that infrastructure can be amortized across hundreds or thousands of services for billions of people. So sometimes we just have to bite the bullet, perhaps with cooperation from the satellite providers, from the cloud providers, and so on, and make it happen. It's worth mentioning that these are all good things that are happening or could be happening with AI right now. But there are some not so good things happening. So here's a recent headline from Forbes: is Facebook doing enough to stop racial bias in AI? I suppose the best that could be said is it depends who you ask. There are increasing signs that AI systems are going to be able to impersonate individual human beings in ways that are indetectable, at least through in cyberspace. Just for fun, here are 4 people. So if people would like to guess which of these are real people and which of these are completely computer generated from one of these generative models. So you can look at that, decide who is the most human on this page. And while you're thinking about that, we can also mention the use of AI for manipulation, for misinformation, for surveillance, for control. This is really a growth industry, unfortunately. And the answer to my previous question was they are all fake people. There aren't any real people on that page. AI can reduce the cost of all kinds of industrial activities, including mining, but of course that means it also accelerates the rate of resource extraction. This is a fully automated iron ore mine in Northern Australia. And we can use AI systems to kill people. And in Geneva, negotiations are happening. So actually the group of government experts is beginning, I think this week, to talk about whether we might put any restrictions on the use of AI for killing people. So creating fully autonomous weapons is, in my view, an extremely bad idea. But so far, there's essentially no real progress on constraining that technology. In the coming decade, I think we'll see, as I mentioned, this sort of pendulum swinging back to the parts of AI that complement the ability to sort of extract predicates from raw data, which happens in speech recognition, in image and video understanding, and so on. And so there'll be more focus on knowledge and reasoning. And I think it's quite likely that if you said the last decade was a decade where computers learned to see, I think this decade will be the decade where they learn to understand language in sort of a real way, right? Not in a superficial parrot kind of way, but they're actually able to extract and reason with the knowledge that is contained in language. And that's really been the obstacle to having real AI-based education. The fact that the AI system does not have any way really of communicating with the human being. in almost none of the AI systems for education that currently exist can the human being just ask a question and get a meaningful answer. So the AI systems don't have a language in common with the human, and in most cases, the AI systems don't understand the content of what they're teaching. So they can't reason about it and they can't really answer questions properly. Also, with the ability to do reasoning on significant complex models of human physiology and disease process, you can start to deliver high quality healthcare. Again, this is a big upfront cost. Developing those models is expensive. And there are lots of prototypes that have shown that this can be incredibly effective. But we still need to really put in that effort to create comprehensive models of human health, the human body and the disease processes. But the important point is that we are all human. And so that effort amortizes across 8 billion people. And so it's worth doing. We could also have AI systems that really work on behalf of the individual human. They're an assistant, a guide, a legal advocate, an agent that operates on our behalf to interact with the increasingly complex ecosystem that exists in cyberspace. Instead, rather than having an agent right now, if you look at your cell phone, you have 50 agents operating on behalf of giant corporations sitting in your pocket. And you have to ask, is this really how I want my life to be? And these agents, so this is sort of an analogy, right? If we look at simulations of what happens if we have 5 to 10% of vehicles being self-driving cars, it turns out that because of their greater speed of reaction and their sort of smoother driving style, just a very small fraction of self-driving cars can reduce traffic jams that arise out of the interactions among humans. So this is maybe a little optimistic, but my hope is that by having these personal assistant agent AI systems operating on behalf of individuals, they will smooth out some of the coordination problems that lead to societal breakdown, to conflict, war, and so on. And as I already mentioned, we will have the ability to dramatically improve the productivity and therefore reduce the cost of many of the complex operations of our civilization, transportation, construction, and so on. So what consequences will this have? In addition to significant increases in GDP and possibly dramatic increases in the standard of living in developing countries, what some people have pointed out is that it's not obvious what role there will be for humans in this new world. And I think this is a subject on which I could give an hour-long talk. So I'm just going to say, I'm going to leave that there. Perhaps people will have questions about it. Now I want to look a little further ahead to when we have systems that are comparable or in fact better than general human intelligence. And to try to explain what the consequence of that might be, I want to take you back in time to 1800. So if I was in, let's say I was in London or Geneva, and I wanted to get to Australia in 1800. So roughly speaking, it would be sort of 1,000 people working for 10 years to acquire and fit out ships and get a crew and all the rest of it. Roughly about $1 billion in present day money, and I'd have about 80% chance of dying on the way. So pretty expensive, a very long and arduous task. Now I take out my cell phone, I go tap, tap, tap. And for around $1,000, I can be in Australia the following day. So relatively speaking, the cost has disappeared. And that's because of technological progress. And also, I probably would be alive when I got there. So we can think now that travel is basically a service. It's sort of available on tap whenever you need it at relatively low cost. We can also take that same idea and apply it to pretty much everything else if we have general purpose AI, because general purpose AI takes all the cost out of the entire supply chain. And the only things that we actually pay in all economic systems are people. And so if you're able to produce things in ways that are completely automated, from resource extraction to final delivery of the product or service, then things can become extremely cheap, as has already happened with travel. So something that we currently think of as taking a long time, requiring a lot of expensive people. So a simple example might be running the AI for Good conference, and maybe in 2035, we'll just say, oh yeah, say to our AI systems, time for AI Good conference, make sure this happens, and it happens. But also things like building houses and schools and hospitals and roads, which require right now expensive, well-trained, well-organized humans, and the organizational infrastructure that supports them is all very expensive, and in many cases beyond the capabilities of certain societies. So we can also think about teaching children, training surgeons, again, very, very expensive and not done in many places because it's just too expensive to do it. So the kinds of systems I'm thinking about are not what you see in science fiction, right? The robot which is sort of carrying its brain in its head, so to speak, but you know, essentially a global AI system, a global cloud, if you like, that just happens to have physical extensions of various kinds, you know, legged robots, wheeled robots, flying robots, and think of the robots as just sort of physical avatars that the AI system can move to anywhere that needs those physical capabilities to build stuff, to fix stuff, and so on. So if we had this capability, then I think just conservatively, not mentioning the sci-fi stuff about you know, curing cancer and having people live forever and traveling to the stars and that kind of thing, but just what we already know how to do, but we don't do because it's too expensive and we haven't developed the productive capacity to do it. We could lift the living standards of everyone on Earth to a respectable level, which I put arbitrarily at equivalent of about $100,000 a year per person. And this would be a roughly 10-fold increase in the GDP of the world. And I think this is entirely achievable. And if you calculate the net present value of that, it's 13.5 quadrillion dollars. And so that's very roughly the size of the prize that we are aiming for in AI if and when we achieve general purpose human level intelligent capabilities. And when you look at that number, it puts the numbers that you see in the news, you know, the 10 billion EU programs or the 150 billion China programs and so on. It puts those in perspective. They are absolutely minuscule, almost negligible in comparison to the potential economic benefit. And if you think about it, right, the general purpose AI capabilities coupled with their physical appendages become essentially a source of wealth that you can just call on whenever you need it. So for societies to be fighting over who has a bigger share of this wealth will become meaningless. It'll be like fighting over who has more copies of a digital newspaper. So we'll still find other reasons to kill each other, religion and politics and so on. But conflict over access to the wherewithal of life, which has been the sort of primary story of human development, is possibly going to become a thing of the past. So all this is good, and it relies on this simple observation. So just as AI systems make better decisions than humans on the chessboard and the Go board, we are gradually moving that from the chessboard and Go board out into the real world by creating the ability for perception, modeling, reasoning, forecasting with real world models and real world entities. So this is a very important step in the development of human civilization. So what does it mean? Well, Alan Turing thought about what this means. And we all know Alan Turing as the founder of computer science, and in many ways also the founder of AI. He talked a lot about how we might go about creating AI, including doing things like machine learning. But in 1951, he gave a talk on the radio where he talked about the prospects. And he said, it seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control. And he offers no solution to this problem, no mitigation. He simply offers, I guess you would say, resignation. So let's try to understand why he's saying this and what the problem is, and perhaps we could fix it. And to understand where the problem arises, it helps to understand what we mean by artificial intelligence, at least under the standard model. And I call this a standard model because it is not only the way we think about AI, but also these other disciplines, control theory, statistics, operations research, economics, and so on. We create machines that optimize an exogenously specified objective, right? We define the objective, the machine then goes off and carries out the plan that it computes to achieve that objective. And that seems very natural. The problem is we don't know how to specify objectives completely and correctly. And in fact, we've known this for thousands of years. And if you create a machine that is optimizing the wrong objective, you really have a problem. And you have a much bigger problem when that machine is more capable than human beings, right? That is making better decisions in the real world in the pursuit of an incorrectly defined objective. So King Midas said, I want everything I touch to turn to gold. And the gods, the machine in his case was the gods, does exactly what, they did exactly what he asked. And then of course his food and his drink and his family all turn to gold and he dies in misery and starvation. In Goethe's story about the sorcerer's apprentice, the apprentice bewitches the brooms to fetch water, but he fails to specify the objective of how much water they're supposed to fetch. And if you happen to rub a lamp and see a genie, the genie will give you 3 wishes, and your third wish is always going to be, please undo the first 2 wishes because I've ruined everything. So we've known this story for thousands of years, and yet we ignore it. And we're ignoring it now with social media, for example, where we build algorithms that maximize click-through, and we hope that those algorithms will do that by learning what people want. In fact, that's probably what the social media platforms thought would happen. The algorithms will learn what people want, and that's good. Unfortunately, the algorithms learn to modify people to be more predictable, because the more predictable you are, the more you can be monetized. And they can make you more predictable by feeding you certain sequences of content that modify your brain so that they can generate more money from it. And that's how reinforcement learning algorithms work. And so you can see that in this standard model where we specify objectives, the better the AI, the worse the outcome, because the AI system is more capable of messing with more of the world in order to optimize this incorrectly defined objective. I'm going to skip over this slide. And there's a new model, which Amir mentioned is in the book Human Compatible, where we actually explicitly acknowledge that the machine is going to be uncertain about human preferences. So the robot's goal is to satisfy human preferences about the future, the whole future. But the machine knows that it doesn't know what those preferences are. This sounds like a difficult problem to solve. It is. It's much more difficult than if the robot knows what the preferences are, but I'm arguing that we cannot achieve that. So this really gets down to the definition of when we talk about AI for good. What is good? We don't know. And so we can't tell the machine exactly what we mean by good. And therefore the machine has to operate under uncertainty. And you can turn this informal idea into a formal mathematical framework that we call the assistance game. It's a game because there are two players, or in general, n players, but imagine just one person and one machine. The machine's goal is to help the person achieve their preferences, but it's only the human who actually knows what their preferences are. And when you solve those games, you find that the machine behaves in a very different way. It doesn't have this single-minded pursuit of the objective at all costs. It will defer to human requests. It will ask permission before taking any action that might be risky or dangerous to the human. Unlike classical AI systems, it will allow itself to be switched off because it wants to prevent accidentally doing something harmful to the human. And in this model, the better the AI system, the better the outcome, because it's better able to learn about our preferences from observation, and it's better able to satisfy those preferences. So if you're understanding anything I'm saying, right, you're probably already thinking, but what about, okay, so yes, what about many humans? How does an AI system make decisions on behalf of not one human, but many humans? And of course, when, in this context, in this meeting, we're really talking about, to some extent, the entire human race. And obviously, this is not a new problem. This is something that people in philosophy and economics and political science have struggled with for thousands of years, literally. I don't have any special insight into these areas, but there are ideas out there in these disciplines that provide at least partial solutions to the problem of how do you deal with heterogeneity in people. That's relatively straightforward. How do you deal with conflicts in the interests of individuals that require trade-offs? There are ideas about that. Interestingly, we can take the same notion that I'm arguing for AI and apply it to governments. And in some ways, this idea was already there, but I think it sort of got lost a little bit. We should think about governments in the same way that we think about beneficial AI systems. They're beneficial to the extent that their actions can be expected to achieve our objectives, the people on behalf of whom the governments are supposed to be operating. And when you think about things this way, you actually get some interesting ideas for how you might think about running the relationship between governments and peoples. We also have to deal with real humans. Humans are imperfect, so the connection between our true underlying preferences and our observable behavior is a complex one that we have to understand better through cognitive psychology and through neuroscience. So I want to finish by asking, how much AI do we really want? I think there are many really incredible opportunities to use AI to benefit people. But is there a limit to how much AI we should have? So I think that AI can enhance human autonomy, that it can free the individual from the sort of straitjacket of need and obligation that many people find themselves in, and provide much greater human autonomy. It can give us more freedom to choose how to live, and it can give us tools to make good use of that freedom through learning, through through guidance, through advocacy on our behalf, to help us actually use that freedom to live wonderful lives. At the collective level, I think it can really help with collective problem solving and eliminating the sort of coordination problems that constantly bedevil attempts to get everybody to work together and solve the problems that we all know about. So this could give us a choice about what kind of future we want, rather than sort of constantly responding to crisis after crisis and struggling to meet the needs, the basic needs of people. We could actually think about what kind of society you might want. This may sound a little bit utopian, but I believe it's possible that we can actually achieve some degree of agreement between our preferences about what the future should be like and the reality of what the future is going to be. Now, if that's the goal, it's worth thinking about the fact that there are many such stable solutions, right? The self-consistent solution where the preferences and the reality agree. There are many such solutions because the preferences, as I've talked about, are undetermined. And in fact, we have, to some extent, a degree of control about the preferences that human beings have. And you could think about social systems, certain aspects of religion and socialization of individuals as a way of creating pro-social preferences in individuals. So how we choose to design the future is also a question about what preferences should humans have in the future, so that not only do we have agreement between preferences and reality, but we actually have a self-consistent solution that we feel is worthy of the human race. We don't want so much AI that we become demotivated and enfeebled. And I think this is a really important point as we look into the future. If AI systems are capable of taking over the management of our civilization, then for the first time in human history, we've gone through tens of thousands of generations where the passing on of civilization to the next generation has been absolutely essential, because otherwise civilization would end. But for the first time, we no longer need to do that. And then that creates the question, well, if it's no longer necessary to pass on our civilization to the next generation, then why would the next generation bother to learn about it, to learn how to run it, to recreate in their own minds all the knowledge that the human race has accumulated over its history? And this point was made in a story by E.M. Forster, who didn't usually write science fiction. He usually wrote novels about English society and its foibles. But he wrote a very powerful story in 1909 called The Machine Stops. And I highly recommend that story as a cautionary tale for over-reliance on artificial intelligence. And you could see the same thing recurring in Wall-E, where essentially the human race is on a cruise ship and the cruise goes on forever, and that doesn't have positive effects on the vigor and autonomy of the individual humans on the ship. So to summarize, I think AI is already helping to solve global problems, and as the technology progresses and as we put in the collective effort to apply it, we will see more and more benefits on a global scale from AI. But it's also creating some global problems, and as the technology accelerates, it will the problems that it's creating through its misuse will also accelerate. The main point of my talk is that when we say AI for good, we do not know how to define good as a fixed objective in the real world that could be supplied to standard model AI systems. And if we do that in the limit, then we will find that we lose control over AI systems that are pursuing these fixed objectives, even when those objectives are actually not what we really want. They're actually in conflict with how we want the world to be. So this requires changing AI to a new foundation that allows for what we call provably beneficial AI. And lastly, I just want to point out that AI is not a panacea. In fact, you can see this very clearly in the absence of progress on a lot of problems where AI could be helpful. The problem is one of human coordination, determination, and let's not forget that the solutions to our problems really are up to us and not up to a technology to solve. Thank you.
Thank you very much, Stuart. As always, an amazing overview and talk about not only history of AI, but also where AI stands today. We had a lot of questions from the attendees and audience about not only definition of good, but also where we stand today in terms of levels of AI, or from a scale of 1 to 10, where are we today in terms of AI? And you and I have been discussing many times the fact that many believe that by 2050, we may have AGI, or maybe have later or sooner, but is that really matter today? Should we be thinking about how far AI can go, or should we think about immediate actions on AI today, and how it should be governed to begin with? So the question is that where are we on 1 to 10, and how should we think of AI today in 2020 before we go too far out?
Yeah, I think these are important questions. We are still, in my view, a long way away from the kind of AI that would present an existential risk to humanity. I think there are major breakthroughs that have to happen, and those are very hard to predict. So I almost always avoid giving any kind of timeline, but I'll just say that the vast majority of AI researchers believe that human level or superhuman AI will arrive in this century. So you could think of it as a timescale similar to the arrival of massive catastrophic effects from climate change, for example. The problem is that we don't know how long it'll take to solve the problem of control. Right? I mean, if you think about it, right? Systems that are more intelligent than us are more powerful than us. They have more power over the world than we do. So how do you expect to have control over more powerful systems forever? Right? So it's, at least, on the face of it, not an easy problem to solve. And we don't know how long it's going to take to solve that and create a kind of AI that is provably beneficial and safe. And people are investing at enormous rates, and thousands of incredibly brilliant people are moving into the field. So for someone to say, oh, it's so far off, we don't need to worry about it, I just say, go back and look at the history of nuclear physics, where the expert consensus was that extracting energy from atoms is completely impossible. And yet, literally the next day, the nuclear chain reaction was discovered, and then nuclear weapons were created in a few years after that. So we can't be complacent about this. There are problems that are happening right now: autonomous weapons, bias, misinformation, manipulation, surveillance, impersonation. We absolutely have to address these now, because they're going to get very much worse very quickly. Down the road in Geneva, they're going to be talking about autonomous weapons. And if we don't do something about that, we will have a new class of weapons of mass destruction that will be cheap and easy to proliferate and extremely effective at wiping out entire cities and countries. So let's not do that.
Talking about governance, it seems that it's hard to govern topics that we don't have full understanding of. One, in terms of the sustained growth, the investment that is required, the amount of knowledge sharing and education that has to be provided, and how to protect people and society. And Future of Life Institute, for instance, has initiated a lot of AI safety research helped by Elon Musk recently. So at least that field is growing in terms of AI safety. But we seem to have a need for not necessarily governance, but probably iterative policy making and understanding how to continuously monitor some of these aspects. How an individual that doesn't have a PhD or doesn't understand machine learning, or basically a normal citizen, can be involved. How can each one of us participate in this conversation and these topics without being just a layperson listening to the news and fearfully hoping for the best?
Yeah, I think it's very hard to understand from the media what's really going on. I mean, the media either sort of talk about Terminator robots, and I have this sort of standing agreement with journalists that I won't talk to them if they put a Terminator robot on the article, because I think that's really confusing people, right? It's constantly this idea that, oh, the thing we need to worry about is AI systems becoming conscious and evil, right? It's nothing to do with that. The thing you need to worry about is AI systems being good at what we tell them to do, right? And the problem really is we don't know how to tell them what to do properly. So we need different kinds of AI systems that don't work that way. But I think you have to educate yourself. You have to learn what are the limits of what AI can do right now. There's an awful lot of hype. And as I tried to show with the example about the vision algorithms that are not actually looking at the objects they're supposed to be recognizing, just looking at the background, that the capabilities are still very fragile and fragmentary. There are some narrow tasks that work well, and you could apply it to some other tasks that you think would work well, and it doesn't work at all. But I think for the ordinary citizen, the opportunities to get involved are somewhat limited. You don't really have a direct access to the giant tech corporations, and you don't really have access to the policymakers. The EU Commission right now is involved. There are sometimes avenues for public comment, but I think the best thing to do is to do things like writing letters to a newspaper comment page or doing op-eds, but you have to learn about the issues first in order to know how to modulate and direct your involvement.
We have time for one more question, and gathering there are many questions in Q&A, and we might not have the time to address them all live, but we'll try to address them separately. As we talk about sustainable development goals as a framework to solve global problems and to make the world more sustainable, you give a number of good examples of AI already making a difference and impacting some of those SDGs. And having in that, there are going to be some negative consequences or lack of control. But as we get more aware and more informed, more educated, you also said that we can probably use AI to collaborate more and eliminate inefficiencies. Going back to the SDGs, where do you suggest we put our emphasis today? Where should we collectively work hand in hand and collaboratively to show the value of AI for the global good and for SDGs, and where should be those priorities for us?
So I'm very optimistic about applications involving satellite imagery, because that's a new perceptual capability that didn't really exist. Mostly it was in the hands of governments and militaries, but now it's sort of democratized. There are several companies who have hundreds of satellites up there, and we can image the Earth at higher resolution every day. If we can make that information available, we can do all kinds of things. I mentioned deforestation, but famine detection, tracking migrations of animals, looking at dehydration of ecosystems, shipping, fishing, and so on. So environmental monitoring of all kinds in a generalized sense, looking at understanding the the growth of cities, the movement of people, et cetera, et cetera. I think there are, people are much more creative than I am. They will find thousands of ways to use this if they don't have to spend $1 billion up front. Right, so we collectively, the UN, the governments, the tech corporations, the satellite corporations have got to spend that money. But what we found with the global seismic monitoring for the UN, so the UN CTBTO spent $1 billion to build the sensory network and the data transmission capabilities and so on. To actually do the AI part was basically about $500,000. Right, to create a new monitoring software system that was much, much more effective using AI. So I think that's the kind of ratio, right? Once you put that money in up front, creating a new 24/7 global service would cost on the order of a few $100,000 to a few million. And the benefits could be enormous. The other area, I think, building on expected progress in reasoning and language understanding over the next decade, I think is education. Because with those capabilities, you can finally sort of meet the dream of AI tutoring systems. And we've known actually for a long time that individual tutoring can be about 3 times as effective as classroom teaching. So a classroom with 20 or 30 students versus individual tutoring, the same skills, knowledge, capabilities can be transmitted 3 times faster. With intelligent AI tutoring systems, everybody who has access to a cell phone can have access to an extraordinarily effective education.
Well, this is very encouraging, and we always have great pleasure to not only listen to you, Stuart, but also share this journey with you. As we have designed this program of the past 4 years, I think you have helped us not only understand the limits of AI, but also always have this, while you're carefully warning about safety and issues of AI, you always have been demonstrating this positive outlook also about humanity and reasoning and thinking first.